So welcome to this session that we call the Streamlining Cloud Native Development. The goal of this session is to introduce you to tools or to tools that you already know that will allow you to simplify your daily life as developers, managing dependencies, but also giving you more confidence in testing the software you will have to release. Okay? So just to introduce me a few minutes. So my name is Laurent, Cloud Native guy, developer. I've been in financial services for years. I've moved also to cloud vendors, open source vendors. I've been at Red Hat before. Love everything distributed. So whether the spec size of stuff, Open API, Async API stuff, and Kubernetes, of course. And as of today, I'm working at Postman. You probably know Postman, the HTTP API client. So I'm not working at all on that part, so don't ask me any question on that part. In fact, Postman is sponsoring the work I'm doing on Microcks. Microcks is an open source project, and I'm fully dedicated to work on Microcks. So thanks to Postman, I can now, just focus on Microcks. And on the personal side, yes, I'm a data gardener, pastry lovers, and we will talk about pastry later on. Okay, so basically, this talk will be, I think, something like 15, 20 minutes of introduction, and then we'll go in deep diving code, just doing stuff, and you will be able to follow up, to follow on using the GitHub repository or try to do it yourself simultaneously, because there is not that many people in the room. I think we can be very, very interactive. So don't hesitate to interrupt me on any question, whatever. I think the goal here is to be sure you understand everything. We don't want to rush. The goal is not to rush to the end of the workshop, but much more to be sure everyone understands everything correctly. Okay, so before starting, who is developer here? Good. Who is a Quarkus developer or Java developer? Great, okay. Who is working with microservices, architecture, SOA stuff, modules, or whatever you call it? Okay. Have you ever felt this feeling that sometimes, you know, distributed architecture is nice because you can mix and match, gather together many pieces that are remote, but sometimes you've been a bit too far and you introduce the extra dependencies that makes your system complex to debug, complex to troubleshoot, but also complex to set up from a developer perspective. Okay, I'm sure you already had this feeling. That's true because life is difficult. The life as developer is difficult. One day, a few years ago, life was easy. We just had one single command, mvn something. Then we have new build tools that came in, Gradle, whatever. Then we have new stacks. Then we became full stack developers. So we had to run the UI using NPM, or we had to integrate some of the microservices running in Go. Then Docker came and you found it was a nice idea to manage everything using Docker Compose, but you still have legacy stuff like legacy shell scripts you need to manage. So as a day-to-day life, it can be a real burden to manage everything. I don't know if you already faced this issue of this cognitive load. What is the script that I should launch now? I don't really know. So you have these notepads with all these commands. Yeah, it's a nightmare. For your machine, it could be also a nightmare because at first it was easy. You just have the application you are focusing on, but then you have the dependencies that can be packed as container. That's nice, but they have also their dependencies. Each microservice may have its own data store, its own database. So finally, you end up putting everything onto your Minikube, kind, whatever, cluster on your machine. And then you burn a lot of CPUs. wasting a lot of time waiting for things, for infrastructure stuff to be up and running. But in fact, at the beginning, you just want to test your local application, okay? So lots of complexity, lots of carbon footprint, lots of energy, lots of waste of time and money. And that's why I think the project I'm working on, Microcks, can save your life as a developer, can ease your life as a developer who are facing this kind of issues. So Microcks on microcks.io is a project I started some years ago, and that is fully dedicated to mocking, API mocking, service architecture mocking, and testing. Okay, it is now sorry, it is now a CNCF project. We joined the CNCF 2 years ago. We have Sandbox project, and you can get much more information on this website. And you can see by the little diagram here that the purpose of Microcks is just not to provide some helpful tools for REST API developers or GraphQL API developers. No, what we want to do is to provide a very uniform way of addressing stuff, whatever the kind of service, whatever the protocol you're working with. So we have still people using Microcks with, for example, legacy SOAP web services, with new GraphQL APIs, with gRPC services, with asynchronous event-driven systems working on top of Kafka, of AWS, SQS, whatever. So the purpose of the tool is really to provide a unified approach to mocking and testing. How does it work in a nutshell? The main idea of Microcks is not to reinvent the wheel and not having you to write some specific stuff from Microcks. So the starting point is to reuse all the different artifacts you may already have as an organization. So it could be Swagger, Swagger files, it could be Postman collection, it could be gRPC protobuffer definition, whatever. And Microcks is able to ingest all of this or to discover all of this on your different Git repository, for example, and from that, he is able to just produce live simulations of your API. So it understands the different schema, the different syntax, and from those different artifacts, it infers some behaviors and produce live simulations. The more artifacts you put in Microcks, the more information it gets to provide the smartest mock possible. Okay. And when we talk about smart mocks, it could be obviously static mocks, but there are much more features that you can use to really simulate smart behavior from your mock. So you can use some stuff like templating if you want to, for example, reuse some elements of incoming request in the response. You can use some stuff like scripting if you want to simulate medium to complex business logic for your API. You can also decide to have stateful mocks. So if you want to simulate conversations or stuffs like web selling, like having a cart, adding items, then checking out the carts, this kind of stuff, very easy to do. And on the right, on the infrastructure side of things, you can also use Microcks to simulate delays. You can use it to also to compose with existing APIs, proxying to existing endpoints, or give you fallbacks. And the nice thing we're working on at the moment is that we put everything under open telemetry observability so that you get full access on what's going on into Microcks, and you can be sure that if you introduce it into your environment, for example, if you want to build a sandbox using Microcks, this will not be the bottleneck in your architecture. So that is for the mocking side of things. For the testing side of things, in fact, once we have ingested all these different artifacts, we have also the ability to reuse them to build complete and comprehensive test suite for your API implementation. So once you have developed and you are delivering your application, you can be sure that the new version 1.2 of your endpoint is okay, conformant with the latest 1.2 schema specification of this endpoint, but also that you did not introduce any breaking changes. So it's still conformant with the 1.1, 1.0, and so on. So if you're respecting the semantic versioning and want to be sure that you did not introduce any breaking changes, you can use Microcks to automate all of this and just doing a QA contract testing automatically without writing a single line of code. Okay. And of course, can be plugged into your CI/CD pipelines. One thing that is interesting and important to understand is that in Microcks, we just don't have one artifact that allows you to define one API simulation or test suite. The more you put in Microcks, the more, the richer the test suite and the simulation will be. And in fact, we have this ability to have this multi-artifact support. So we still need one primary artifact, that is the one that defines the global structure of your service. And then you may ingest many other supplementary secondary artifacts that will come to enrich your definition and complete the test suite you will use. And we will use that in some minutes in the workshops. Okay, so far so good. Any questions so far? Let me know. 100% clear? Okay. Yeah?
You were mentioning contract testing, but when you say that, it's the contract that you provide?
It's the contract that you provide. You being either the producer of the API or the consumer of the API. Because in contract testing, most of the tools make the distinction between the consumer-driven way of doing things, of doing contract testing, and the producer way of doing things. So here you can do both. One interesting thing in Microcks that people likes a lot is that it's a tool that can be used using many different flavors. Okay, so it can be very lightweight and run on your laptop, in your IDE, in Quarkus DevService, for example, and so on. But it can also be used on centralized and shared environments like your Kubernetes cluster. And so it covers both the inner and the outer loops. And the things that people love a lot is that they are able so to reuse the same artifacts, the same source of truth on the whole lifecycle. Okay, so we will have the ability to cover the inner loop. That's what we are going to dive in a few minutes. And of course, on the outer loop, to be deployed on Kubernetes, to be deployed thanks to operator, to be integrated in a full GitOps approach. So really easy to trigger testing, automated testing in your Argo CI/CD, in your Argo CD deployment, in your Argo workflow, this kind of stuff. Today we will focus on the shift left. Okay, this approach where you can use Microcks through a test container integration. Is everybody aware of what is test container? Okay, no problem. So very easy. Test container in a nutshell is a library that is available on many different stacks and languages that allows you to plug, to start and to stop containers within your favorite language and within your favorite automated testing tool. So basically, there is bindings for Java, Node.js, Go, whatever. So it allows you to just integrate containers within your unit test very easily. And of course, in Microcks, we have this integration with test containers so that you can use a very lightweight flavor of Microcks that is directly started in the setup phase of your test and that is teared down at the end. The workshop today will focus on Quarkus. So I asked before, and there are Quarkus developers in the room. So, and maybe I'm not going to do the Red Hat's job talking about Quarkus, but in a nutshell, you know that Quarkus is let's say, next generation Java framework that is tailor-made for cloud, tailor-made for Kubernetes, based on standards like Jakarta E, and driven by the community. Okay, so I think that's all you need to know about Quarkus. Of course, it's a Java framework. Microcks is completely integrated with what they call the DevServices in Quarkus. So DevServices in Quarkus is a layer on top of test container, basically, that allows you to, as a developer, don't have to worry about provisioning a Kafka broker, provisioning PostgreSQL DB, and so on and so forth. So it just allows you to focus on your app, and by just declaring dependencies, it will pull out and start up all those containers, bind them together so that you have ready-to-use environment very, very easily. And so we will use Microcks integrated into Quarkus Dev Services for the coming labs. You will see in a few minutes, but here the principles are very, very easy. Microcks can be totally invisible just behind your Quarkus application. Okay, so this Quarkus application will rely on base containers for, let's say, infrastructure services like Postgre, like Kafka. But as soon as you have dependencies on other homemade REST APIs or services or whatever, Microcks will be able to start and to serve simulation for these dependencies so that you don't have to pull these dependencies by yourself. And we will see how to use also Microcks directly into your unit test. So writing tests that just pop up all your dependencies, all your API dependencies, and then tearing down at the end of the test. Okay, and I think that's it. It's just a wrap up. So we will focus today on the inner loop, but be aware that we have some nice integration with all the CNCF ecosystem. So whether you want to look at solutions for deploying Microcks on the fly within your CI/CD pipeline, or integrating it with some other component of your developer toolbelt, like schema registries, like internal developer portal like Backstage. We have some interesting connections and plugins for those different solutions. Yeah. And just, yes, wanted to finish the presentation that, so once again, we are not trying to use one problem for one specific type of API, but we are providing really a uniform and a unique approach, whatever the kind of API you're dealing with. So that's also what people like a lot. It's not just one solution for one kind of architecture, but you can really automate on top of that, because you will have probably the ability to manage all the different kinds of services, even synchronous or asynchronous, you're facing in your organization. And that's it. Thank you for the slides. And let's deep dive in the workshop. I think that Romain sent the link already. In the chat, yeah. In the chat, okay. So you may have already had a look at the workshop. Let me just swing by. If not, we're gonna do this here. Okay, so Microcks Quarkus workshop on the Microcks organization. So this is a fictional application, okay, a basic one that will allow you to order pastries. Okay, this is my passion. I recall you. And so this is fictional, but we try to make it looks like most of the application I'm facing on, when being on customers or on adapters. So you should find some things that are very similar to your application. Okay. And so this workshop has been divided in 5 steps. Okay, the first one are the introduction, and then we will see how we can make sure as a developer that the different pieces we are developing, either the front side APIs, either the backend communications pieces, are cleanly developed and are conformant to the specs, so that we will find very early in the development lifecycle all the integration problem that may faced where connecting to the other pieces of the app. Getting started. Okay, so I think these are just the prerequisites here. So having a container runtime, having a Java SDK if you want to run it on your machine. And then we can move forward just to step number 2. So step number 2, this is the application we are going to work on. So as a famous pastry producer and provider, okay, we want to be able to provide an API to our selling or distribution channels. Okay, so it could be online, physical stores, it could be partners that are resellers of our pastries. Okay. Today in the workshop, we are going to focus on the order service that is part of the order domain. Okay, this is the application we are working on at the moment. And this application is relying on other third-party ones. Typically, we have a connection with the product domain, with the catalog service that is responsible for providing a list of the different APIs with a description of API of pastries as a product, with information on the availability of pastries and so on and so forth. Okay. Then we have also connection. So this connection here is a synchronous connection that uses a REST API. Here we also have a connection with the billing domains. The billing domains is the one in charge of checking the payment information, processing the payment information and the payment, and finally, finally just giving a response or whether it can be processed or not. And here the communication with this domain will be done via asynchronous messages using Kafka. Okay. So this is very simple, but we can already imagine the challenge of retrieving these third-party APIs so that you will be allowed to develop in isolation without maybe on the train, on the plane, whatever, in a disconnected way. And also having this ability to set up maybe a Kafka broker, and with the question just after this one, how can I validate that the messages I sent are correct, and that the billing domain will be able to process them, to understand them, and to give me some responses. Okay, and of course, because we have many different distribution channels, we have to be sure 100% that each and every time we touch the code for the order API in front of the order service, we not introduce regressions, we not introduce, and we still allow partners, resellers, and so on to build on top of our APIs without disrupting the service. In terms of internal architecture, very basic stuff. Okay, we have the business logic in the green box in the middle, and we are exposing to the outer world via a controller, and we are communicating with the pass-through API using a client. We also have two different building blocks that are the event publisher and the event consumer. Okay. In terms of business rules, things are really easy. The only thing that we should be sure is that when someone is placing an order, we have to check that the different pass-throughs of the order are currently available within the product system before saving the order and emitting an event saying we have stored an order and please process the payment. Everything okay? Everything's crystal clear? Yeah. Nodding your head. That's okay. And I think that's it. Yeah. So yes, important stuff here. Flow specification. So there are flows going from in and out of our application, and in order to specify them, we have used Open API specification or Async API specification. Are some of you aware of what is the Async API specification? Yeah, so basically, let's say it's the sister specification, the Open API sister specification, but for event-driven systems. So instead of defining HTTP endpoints, in Async API, you're defining asynchronous communication channels and endpoint. And you are also defining still using a JSON schema, defining the structure of the message that will be exchanged on these different asynchronous channels. So very, very quickly put. Okay, and we can go to just the local development experience. So from now, I will switch to the IDE, just demonstrating live. So don't hesitate to interrupt me to ask any question. If you are looking at the code aside and have any questions, feel free to interrupt, no problem.
If you have a problem with the prerequisite, or you can help also.
Yeah.
Sometimes it can be a bit complex if you don't have the virtualization and Podman, might be a bit tricky.
So the point is to code along.
You can if you want, or you just watch. It's the relaxed version.
Yeah, exactly. So to be honest, I will not code from scratch. I will do mostly copy paste. But I think, yeah, as I said in introduction, can be very interactive. So don't hesitate. Okay, so here is just a fresh clone of the application, and let's say, yeah, the usual experience is that you want to just starting your application, starting the dev mode. Okay, so starting the dev mode in Quarkus is just Quarkus dev. And few seconds, we should have something running.
Because you already have all the dependencies.
Oh, I have no dependencies here. So and you'll see that if I just, let's say my application is now running, and if I just want to test it, to check it's working actually. So for example, by making an API call to this order API with some products. So I love the millefeuille. If you want to buy me a millefeuille at the end, I will be more than happy. So if here I'm just trying to save a new order, obviously I've got a 5.0 internal server error because we have missing dependencies. Okay, so typically here, yes, we don't have a client that has been registered because typically I have not configured where is my pastry API endpoint, where it is located. Okay. And so this is where we can start just introducing what Microcks can do for us. So here, no dependency. The first thing we're going to do is just add the Microcks dependency. Okay, just removing the comment from my POM, refreshing everything. Okay, and here I've just used some pretty classic conventions. Remember, I was focusing on the async API files, open API files, and so on. I just put them into the resources. So here in the resources, I can put the different specs of my API. And for example, in the test resources, I can also put the different specs of the dependencies I rely on. So here, typically, I've been to the product domain manager, and yes, get the pastry, the open API for the pastries. I get the one for the asynchronous, and so on. And now, just doing that, starting.
No, just a question. You use a 0.4.2 snapshot in the.
Yes,
It's okay with 0.4.1 or.
yes, it's okay. Just this one has a little enhancement. I will show you later on. So just doing that, you will see that Quarkus now allows us to detect that we have these files, now that we have the Microcks dependencies, and it has started additional services to complement your local setup. Okay, so now if I'm looking at the if I'm looking at the running containers on my machine, look up, yes, you can see that there are way more containers, and typically you will find here the Microcks, the main Microcks container. So just now trying again, issuing exactly the same command. Okay, now I have an answer because Microcks has just been integrated in the project. It has detected that some Open APIs files, Swagger files, YAML files were there. It has discovered your service dependencies and it has wired them into the Quarkus application. Magic, no. So if we are now going to the Quarkus Dev Console, Dev UI here, you can see that here we have this Microcks Dev Services that has been added. And typically you can access the Microcks UI that allows to say, yes, I have discovered these different APIs, these different services, and I have discovered their operations. So here, for example, for the catalog APIs, I have 3 different operations. Okay, and also because you gave me Postman collection, YAML files, and so on, I have also discovered samples that allows me to produce yes, simulations. So typically, I have discovered the samples related to the millefeuille. I know what a millefeuille is, and now you can ask me about millefeuille. That's it. And it has wired everything into your application.
And it takes into account what you had already in the projects because you had the YAML files, right?
Yes.
So if you have also like mocked responses for Quarkus test, for example, it also takes that.
It depends how you have defined those mock responses. As of today, we rely on standard or de facto standards artifacts. So most of the things that are, yeah, if it's just Java code, for example, we are not discovering this.
Yes, You do a mock server
programmatically,
or
yes.
you inject a Quarkus mock and you.
Yeah,
you
no,
discover-
no. Here, the point of Microcks is much more to be able to centralize those mock definitions, to share them also with the different people, different actors on the whole life cycle. So that's why we are much more relying on standard artifacts for gathering all this information.
Okay, but like, so that data about the build way, where is it exactly? Like, what is the artifact that had it?
Yeah, so
Something like specific?
no, it could be, for example, it could be directly in the OpenAPI files, because, for example, you have this ability in OpenAPIs to describe examples. So it could be one source of those samples. It could be Postman collections, if you already have Postman collections. It could be basic YAML files. We have this YAML file support here, where you directly define examples. So it could be many different things. For everything related to HTTP API, it could be also recording of your live traffic. If you already have an API and if you are able to record and to extract an HTTP archive, then Microcks is able to discover this one and to complement the existing simulation with this data. See?
Can you add a YAML at runtime, or you need to read?
Yes. And thanks to the DevService and the dynamic behavior of Microcks, you can add new files, you can modify existing files, you can add samples and so on at runtime without reloading the application. It's just the dev services that detect that and that reload and that refresh the samples into Microcks definition.
So you add it inside the resource folder, not from the button on the UI. I don't know if there is a button on the UI.
No, there is no button of the UI because here, once again, one of the principal Microcks is to reuse shared artifacts that are the source of truth. So we don't want to be able to edit the mocks in Microcks, just reuse source of truth.
But you can still upload in the dev UI, could upload is the upload of the YAML.
That's
Yes.
the button I was referring
I
to.
think that's the one.
Yes, yes. So here, for convenience, I've used files, artifact files that are in my project, but I can also reference remote artifact files, and I'm still free to to decide to upload new stuff, to integrate new stuff that are not in my project. Still working. By doing that, you are losing the dynamic way of doing things, but it's working correctly. Okay. Get it? So first thing first, you can see that yes, having Microcks here directly integrated allows you to test different stuff. So for example, let's say I want to query another pastry, this one, for example, éclair au chocolat. Éclair au chocolat, yes, receive another response because this one typically is not available because I have a sample in my JSON file, in my YAML file somewhere that tells that in the description of éclair au chocolat, it's not available. So it allows me, the more samples I put into Microcks, the more I am able to represent different use cases, different edge cases, and so on, error cases, this one, so on and so forth. Right, everything okay? So obviously you can, one thing that can be interesting is that you can then configure many things about this dev service. So here it's in auto mode, but you can also, as I said before, define remote artifacts. You can also completely configure the images you are using, and One thing that is you can disable the dev service. One thing that is interesting typically is that we have if you're like me and if you are obsessed by having an environment that starts very quickly, you can also here put your custom image, and typically from some time now we have native version of Microcks. These are native compiled image that allows to start very quickly. So starting again, let's say, and check the containers. Yes, not yet. Okay, some network issues on my machine. Where is, yes, and let's see, for example, this one. So here, it discovered everything, but you can see as the startup, where is the startup message? Yes, here. Yeah, 200 milliseconds, so quite fast for starting and wiring together all your dependencies.
Do you have the ratio between the two? How much you win? Like, what's the saving in terms of time?
It's 3 or 4 seconds, something like that.
Less.
Yes, exactly.
Because we experienced some issue on our side. We are testing with this, with the normal image, and our tests are very long because Microcks is starting and stopping the container at each Quarkus test, even unit test. I'm not sure, and yeah.
Normally not if it's a Quarkus test, not a Quarkus integration test. I think it should be just started once, and that's it.
It might be some configuration that blocks your service, your test container to be retaken back by the next test. Sometimes
The test profile is different or something like that.
Okay.
Detect something has changed and it said, sorry.
Because we have different test profile, of course, between each test. So it's starting, and so I think our tests are taking 20 times more than with Waymock. So maybe this is a solution that could at least reduce this.
Yes, because sure. It's not yet the default in the dev service because we have them for quite a while, but still very experimental. You know, if you already try to compile stuff using GraalVM native, you know that you got headaches. So it's still not opt-in by default, but you can have a try and switch to the native mode to see things are getting better.
Because you are using a Spring Boot and not Quarkus. Why you think it's
Probably, I think, a part of the answer is that yes, the Spring Boot support for GraalVM is, I think, not as better as not as good as the one for by Quarkus. Yes.
Do you know if we have a copy of this native image in our Artifactory?
Yeah, you have to use the remote repo for Quay. I think I can find it. In fact, Laurent, question, the way to specify the tag, it's also a way to freeze the Microcks version because these Microcks version are released independently from the Quarkus Microcks extension.
Yes.
They point to latest.
Yes, exactly.
Major version. So if you want a reproducible build or something, you need.
It's important to dissociate both and having one version of the Quarkus dev service that is set in the POM XML, and then having the version of the images in your application properties. Yeah. Excellent. And by the way, you can see here that in the console, there is these are those logs that tells you that we are here receiving messages. And this is because here again, if we are looking at the asynchronous side of things, we started Kafka broker, and Microcks has been plugged into the Kafka broker. It has found some samples of asynchronous messages that are expected to be received. And here it just acts as an external producer of messages, sending you messages on the frequency you've defined. So here, yeah, we're still receiving messages continuously. So here again, very easy to check that your application is behaving correctly on the reception of such messages.
Is this definition of like the frequency of the messages like one value by default and then you can override it somewhere, or you need to specify?
You can override it. It should be something like 3 seconds by default, but you are free to override it.
Where exactly?
You can either choose to have to use an async API extension that is x-microcks, and you can specify the frequency, or you can have an extra another artifact that allows you to specify a bunch of Microcks metadata apart from the async API file. Yeah, sounds good. Okay, so I think that's it. Yes, creating an order. We've gone through that, so that's okay. Getting details. Yeah, we can check the artifacts to see where the data is coming from. So I think we've addressed those things. Is everything okay? Is everything clear for you? Yeah? Okay. Jumping to the next part. So now we are going to write some tests, okay? Because we are good software engineers and we want to automate everything. We want to sleep at night and be sure that what we shipped is actually conformant. So first thing here is that we are going to write tests for checking our REST client, because you know that we have defined a pastry API client. So let me just close all the tabs. And here we have defined in Java here, the client, pastry API client. It is annotated correctly with microprofile annotations, JAX-RS annotations. So a typical way to do that would be to define a mock object and just be sure that we are calling the correct method. But here we want the full test. We want to be sure that is what is actually sent and what is actually serialized. Transfer from your Java object to your JSON and serialize on the network is actually correct. Okay, so here we are going to write a test for this pastry API client. So as I said before, I'm just going to do copy paste stuff, just focusing on the logic. So let me, how did I, yes, pastry API client test. So new Java here. And we are going to, yes, take this block. Yes, imports. So should have also
There's a setting in TG to auto-import stuff.
really?
I don't remember what it is.
No, that's it.
To import and paste.
Okay, so that's it. So here, this is a Quarkus test. Okay, it will start our application for before doing the test. We will inject and receive a REST client. Okay, and we will just call the method here, checking that we got the expected results. Okay, so just running this. It's still running. Yes. Just running this. Okay. So here the same thing is that Quarkus will start, will launch the different Microcks container, will bind everything together. And this time we will have this ability, yes, to actually retrieve pastries. Okay, so here, what we are checking is that we have the correct number of pastries of small size, of medium size, of large size, and it totally depends on the samples that are in our artifacts. Of course, from the moment I change my artifacts, this test will be broken, but at least it allows to detect very early in the life cycle or on a refresh, a new version of the artifacts that you are effectively running the latest version. Yes.
Here you are testing the artifacts, the metadata you provide to the mock. You are not testing the business logic.
Here it's just a simple client. We are not testing the business logic.
Okay.
We are testing the mock. We are testing the client. Perfect.
Client.
Yes, but the client is bound to a mock. Is wired to a mock.
Okay.
But this allows me to check that yes, this typically I'm able to read when I'm asking for a millefeuille. I'm able to read the status back, get the correct status, and remember a few minutes ago the eclair au chocolat was not available, and here I'm checking that I'm able to read back to deserialize the status from the JSON response from the Microcks mock to my pastry model object. So here you can see in few milliseconds everything has been started and just run, and you're not only checking a mock invocation of the client, but you're checking that everything is correctly wired and serialized and goes over the network and come back and is able to understand the response from your third-party service. So here is typically what is done under the hood. Here, your REST client is bound, is wired to the Microcks that has been initialized at the test startup. There are also some situations when you may have, let's say, not really business logic, but technical logic in your clients. Some stuff like, for example, clients at caching, and you are when you're saving the previous responses, for example, and so on. And so if you want also to check this logic, you can add an extra method call here, and you can ask the Microcks container to just verify that it has been called. So whether you're not checking directly the client, but an upper layer in the invocation chain, or if you have a custom client that has some, let's say, technical logic like caching, like invalidation of cache and so on different, you have also this ability to verify that a call has really been issued to the correct endpoint, or that an endpoint has also been called a specific number of times. So for example, if you're doing 10 times the same call, if you have implemented caching, you should not have 10 times a call to the remote API. So here you can do that with the verify method or the get service invocation count, checking before, checking after, and looking at the difference between the two counters. Okay. So this is just
it's working as well for asynchronous, asynchronous, because here it's for HTTP.
Yes.
And if you want to be sure that a message has been produced in the Kafka topic.
Yes, you can get the content of messages and the number of messages as well.
And here it works because the Quarkus tests are not multi-threaded, because they have some limitation on the parallelization of
Exactly, yes.
deliver signature. So it's safe to do the
Just
conserve.
Just to be serializable, yes. Otherwise, yes, it's a mess. Second kind of test we can do is now that so previously we focused on the right part. Here now, let's say we want to focus on this part here. We want to be sure that the API we delivered is consistent, is conformant with the different versions. So with typical frameworks, like for example, REST Assured, or there are other frameworks, you should do something like that. You should use some kind of DSL to say, hey, please issue a GET request to this endpoint. And then basically you have to check everything manually, checking you have the correct response status code, the correct headers, then taking care about deserializing the response content, and so on and so forth. So it's okay to do when you have something that's very easy, but to me there are yes, two problems. The first one is that can be a lot of code when you have a big code base, and most importantly, what you are doing this is actually duplicating all the information you already have into an OpenAPI file. And so I see many people also having drifting problems between what's actually in the OpenAPI file and what has been actually coded using code. And here you will see the approach with Microcks is a bit different, is that we are not going to code all the checking logic, but we are just going to ask Microcks to realize this test for us. And it will be the one in charge of doing this, but dynamically just from the information he gathers in the OpenAPI file. Okay, so to these things, we need a base testing class. So here I'm gonna create the base test one, typically a new base test. There's config property, that's it. And here in my API package, I'm going to, to create this one, new class, order resource contract test, because what we want to do is to be able to do some conformance testing on the order resource API. You know, the order resource API here is a standard JAX RS resource with the post method typically that we want to check. So here, I'm going just to take this one. It should be also the Quarkus test. This one. Okay. I'm going to explain you in a few seconds. Here I have extends base test. Base test. And this one. Should have put everything in the comments. The correct one. No, I don't want the one from JUnit 4. Jupyter API. Okay, so here a few things. So I start by creating a micro-specific object that is a test request. Okay, it's just contain the information I'm gonna to ask Microcks to do this test for me. Here, I have to put the coordinates of the API I want to test. So technically, if I look at the Open API spec, here, for example, Order Service Open API, you can see that it has a title, Order Service API, and it has a version 0.10. Okay, so here I'm just reusing this information to say, use this API definition to do the test. I provide a strategy. There are different strategies available in Microcks for doing tests. Here, we want to do a syntactic conformance check using the elements coming from the OpenAPI schema. And here, this is the endpoint I want to test. And I'm using here this specific alias that allows me to, in fact, target my own application. So a Quarkus test will start the application, and this application will be available from the Microcks container using this alias. I ask Microcks to do the test for me. And in fact, I just have to assert that it is a success. Okay? Very simply put. So that didn't miss anything. So should run the test for me. So here, what Microcks is doing is that it's still gathering all the information from the different contracts, and it acts as an API consumer. So it will reuse all the different samples to play the different API calls, and it will check the results. It will check if the results are confirmant regarding the OpenAPI specs.
Is there a trace somewhere of what Microcks is doing? Because here we can only press the tool, right?
Yeah, so there are traces. Typically, they are under the test result object. So you can inspect the test result object to know how many operations have been considered, how many samples message have been used to hit the target endpoint and to do the checks, and so on and so forth. So here, basically, we can check that it's actually working well. So let's say, for example, that we missed something in our implementation, and we forgot to set the total price. Okay, I'm placing an order. I need to receive a total price for my order, and we forgot to set the total price. Running this test again now should fail. Let's check it. It's slow today. So it fails. It fails, but it's not very helpful. Okay, because here we just used the standard JUnit assertion. Okay, and this is why I'm using the snapshots, is that now we have this ability to use our own Microcks assertions and say, please assert this is a success. And by doing this, we will have all the informations on what's actually wrong regarding our implementation. And here you can see that, yes, we have a problem. The message valid order failed because the required property total price is not found. So I can just, on command, run it again, and that's okay.
You built the wrapper of the assert of JUnit, right?
Yeah, exactly. Yeah.
Structure assert.
Yes, it is.
The pro at structured.
Yes, just a structure assert that takes care about going through the structure of the test result object and checking everything. So there are some other flavors on these assets you can assert on a specific operation, a specific message. So you want, for example, a test to be a failure on this specific message because you know that it is, it is a bad one. So you can reuse this assertions class with different flavors to do this.
It's an assertion class from Microcks.
Yes, yes, and it's just a wrapper on top of open for test based utilities. This was a feedback written by Kevin. I think it was in August or something like that.
Yes. I have a question because when you write the method like that, for me, finally there is no there is only boilerplate code to write this kind of test because there is no specific logic that is behind. You are just testing that all your business logic is coherent with what it should answer. So I was asking myself, there's no possibility, I mean, from the extension to start automatically performance test
yet, but it could be future enhancements. Yes, to have something like a JUnit rule that you just put the name and the version of the service in when you annotate your method, and that's it. It could be, yes.
That's a good one.
Yeah. So if you have any suggestion, feel free to fill out issues and so on, because it's still, let's say, fresh. I think we have this DevService for 1 year now. The extensions on the unit stuff are much more younger, let's say, so really do not hesitate. And obviously, I don't know if you're using continuous testing in Quarkus, because everything could be, all of this could be plugged into continuous testing. So typically, if you are, continuous testing in Quarkus, using it?
No, but not really using it.
Yeah.
Okay.
You have to use the dev mode and
Okay, very handy. Really like it. So typically, you started your server in Quarkus dev mode. You're connecting to the to this one, to dev UI, okay, and you can say continuous testing. Just start, and in fact, the underlying environment, so Microcks and so on, will be reused to just check. And once you change one thing in one class, it should run only the tests that are using this class underneath to run again. So here you have a very quick feedback loop of saying, okay, you broke the API contract, or okay, you fixed it.
It's kind of a PDD. You have this contract you need to implement, and it's read at the beginning, everything is read.
Typically, yes, exactly. Yeah, just start it.
I have a philosophical question, because the contracts with the example you describe, they have some kind of dependency on the database data or on the mock of the system call you do. So there's a bit of coupling. It works it's a contract which works in local with what's in the Git repo. It may not be portable. Once you deploy on a test system, it may be a different example.
Sure, totally agree. There is still this issue of data consistency across different part of the architecture or different part of the system. And here, I would say that there is no magic. What I can say from the feedback I have on other adopters is that they have all the same issues, but this kind of problem used to be a little bit hidden because before starting to use this kind of tools, Microcks, it was hidden, and they have no means to to easily detect which
environment
is
is not aligned or
yes, exactly, or that the seed data you have in your database doesn't match the example that was provided by the guy who specified the REST APIs to consume the data. And so the feedback I have is that this kind of tool allows to detect earlier in the process this kind of inconsistency. But I would say that no magic here. It's still an issue. It's something that has to be addressed by most of the time different people working on different layers of the system. So this kind of test is really helpful to detect the let's say the fact that you're not conformant at the syntax level. But let's imagine that I am introducing a new bad behavior in my system. For example, when I send the result back, I'm not using the product information that coming from the incoming order. But yeah, I screwed things and I just put everybody wants millefeuille, I will put millefeuille in all the orders. Okay, and you will see that doing this, in fact, doing this, in fact, made my test still green. No problem. Because from an OpenAPI point of view, what I send back is still conformant with the schema. It has no meaning from a business perspective, but it's still conformant with the schema. So my tests are still a bit fragile. Okay. And I said before that the testing strategy in Microcks was pluggable. So basically, I can use some other extensions to try to cover this kind of use cases. And here, typically, I will be able to check the business conformance using some of the tools, like, for example, Postman. If you are a bit aware of what Postman is doing, Postman allows you to write some scripts for doing tests. So, of course, you can do exactly the same thing as what we've done before, checking the response status code, checking the headers, whatever. But I think it's way easier to use it another way and much more about describing business constraint, not taking care about the technical stuff, because this can be done automatically from your OpenAPI file, but you can describe business constraints. For example, this script allows you to define that the product and the quantities in the order response should be exactly the same but the one in the question. This is a business constraint. Okay, or another business constraint could be that if you are searching for small-sized pastries, you only get small-sized pastries. This one is pretty obvious, but if you have some REST operations with complex sorting or filtering criteria, this can be helpful. Yeah.
Yeah, I have more maybe general questions. So it's about to know where we can put the cursor about what is the developer is supposed or at what level to all those traces with Microcks, and also about the responsibility of the QA if they want to integrate that, because we talked about pipeline and we talked about the concept shifting left. So we know that at developer side, you are responsible before creating PR, doing all the stuff, but then once it's went to the QA development and they're gonna run their own tests, and even if they're gonna use the same technology, we need to find the right balance, like what, who, and who's gonna do what. So it's about also not also overload about the developers and takes the responsibility from the tester, which they should do with this kind of responsibility. So how we could know where we put the cursor.
The complex question of organizations.
Sorry.
No, so here I would say no magical answers as well, but it's really up to you to define this here. I think the beauty of the tool, and we try to design it that way, that it really allows you by using different artifacts to split things the way you want. So typically, of course, OpenAPI could be one of the first artifacts that allows developers to start. But this kind of stuff could be just complemented by, say, business analyst or QA analyst. And they may come later, maybe in the process, when you realize that you missed one constraint check, for example.
Okay.
Here, the fact that these are different artifacts is the way for producing them at different times and having them in responsibility of different people. So typically, I think there is no direct answers. It always depends, but at least you have the different levels to be able to split things if it matches your organization or life cycle, or to put everything together. It really depends. Yeah.
I have another one. Maybe you will talk about it later next, but is there for a given business test like presenting with Postman a way to load along with it a bunch of response you expect from the client's call that would go along with that request? Not sure if I'm clear.
In the same Postman script, you mean, or independently?
Often, sometimes the way you answer is linked to the way the call is coming.
Yes.
So you would want to load data that is corresponding to the test ongoing. And I don't know if there is a means to do this.
Yes, there is a way to do that, because here, when the script executes, we are injecting context. So typically, you may have could be ugly or not, ifs or switch, then else kind of stuff, that allows you to say, if in the request context I had this kind of stuff, I expect a 200 okay, or I expect an error, or I expect the JSON payload to be formed differently. So you could probably do this by reusing the injected request context. So Postman script for defining business constraint. So here, no overlap with the constraints that are at the syntactic level of OpenAPI, but just, let's say, business rules. And the beauty now is that you can still use the same approach. Let's say your QA engineers or your business analyst has defined this constraint in a Postman file. You can reuse exactly the same approach in your Java code to say, hey, please, now Microcks don't take care about the OpenAPI schema, but please take care about the constraints that you will find defined into Postman collections. And so we can just here copy paste this one.
Can you go back to the previous screen? The test runner. No, just below. You need to get the runner type is extensible. Or it's locked to
Not for now,
for now. Okay.
but we'd like to find a way to make it extensible. And typically, we know that people are at AXA are currently working on having a Cucumber test runner.
Okay.
Because they used to define business constraints using Cucumber files, or
Then you cannot use the Microcks image as is. You need to add your runner top of the Microcks image.
yes. So as it is managed at the moment, is that runners can be defined externally into another container, and we have defined a lightweight protocols that allow to know how to call a runner and how a runner should call back Microcks to provide the results. So
And
there is a start of specification on this, and we'll probably follow up with AXA on this, and if everybody would like to join the effort. But yeah, I think this is the way to go. Is it okay, Kevin? Yeah. So let's here new Java class, this one cancel, and let's this one. So here it's Quarkus test should extend base test, still extend base test. Okay, so you can see basically exactly the same code, just the runner type here that changed. So here I made my mistake, and I can just run this one. It should fail. With the name of the constraint that is not fulfilled. Yes, this one here. Failed the constraint correct products and quantities in order. So I can here again fix my code, run it again, and that's it. So I have tested both things, syntactic checking and business rules constraints are correctly implemented.
But do you still write regular Quarkus test with REST assured on top of that, or how confident are you with? Because yeah, you still have rules which are specific to a call. So how much you may have test the business logic which is specific to a certain value of a parameter, which is
it all depends also on how. If you consider that everything that is not syntactic constraint is a business constraint, and there is a space in between that sometimes does not fit either in syntactic or business, and that can be still useful to check with. Yeah, exactly. I have one. Maybe something I forgot to report here, because typically once you have done your test here, you can also ask Microcks to give you all the messages that have been exchanged. So I would say that it's not necessary to do additional tests. You can have Microcks doing the first pass of checking syntactic stuff, and then ask him to give you the detailed messages and doing your assertions on top of that. So if you, it's not, no, it should be here. I think I forgot something, but yes, you have this ability to, let's say, here, say, it's a Microcks container, get messages for test case. And so, so the test result contains all the test cases and all the test steps that have been executed, but it's just a description of terms of metadata, success, failure, how long, exception messages, and so on. If you want to get all the payload, all the headers that have been exchanged during this test, you can just retrieve them here and put additional assertions on top of it. And I think that's it for part number 4. Yes. Any questions? It's okay. Final part. Most complicated one. So now imagine we'd like to do more or less the same thing, but for asynchronous events, asynchronous messaging. Okay. First things, we will need an additional helper here that is called Quarkus Microcks test. So we are going to just uncomment this part in our pump XML. Let's do some cleanup and okay. So let's say now that I want to check a critical part of my component. I want to be sure that once I place an order in the system, it triggers the publication of an event to the payment system, to the billing domains, I will call them. Okay, so here, a typical way, and I would say a light way of doing this, if you are using frameworks like Mockito or EasyMox, would be to have an interface to define event publisher, to dynamically define a new mock, trigger the place order method on the order service, and then check that the event publisher publish event method has actually been invoked. Okay, so it is helpful, but doing this, you are not checking that you are able to connect to a Kafka broker, you are able to serialize your business, your POJO into JSON or into Avro or Protobuf, whatever. You are not testing that you are targeting the correct endpoint on the broker. And more importantly, you are not checking that the consumer will actually be able to read your message, deserialize it, and process it correctly. So that's where we are going to here again write tests for doing that. So let's start. It will be an order service test because we will check the order service class regarding the event publication. New order service test. Okay, and here I will copy paste here. It's so slow. Maybe because I. Oops. Still slow. Import class, import class. List, okay. Sorry, takes a bit of time. So for the next time, I will learn about the auto import function in IntelliJ.
Game saver.
Also, you have live templates that can help during the workshop or the.
Okay, so basically here it's still a Quarkus test, but I need an additional test resource that is provided by my testing companion. And this testing companion allows me to retrieve the the Kafka broker coordinates. Because we are in dynamic environments, you know, Quarkus DevService instantiates stuff, but we don't know the name of the host, the port it's running on, and so on. So we need this to be able to connect. And here, now it starts to be very familiar. You will still have to create a test request, providing your service coordinates, filtering on an operation here. But with a new testing strategy here, we are checking the conformance regarding the async API schema and the async API specification that is still in our project. We are providing an endpoint, and here it's no longer an HTTP endpoint, but just a Kafka endpoint. We're using the internal endpoint that was created dynamically by Quarkus and so on. Okay. So we are preparing this test request, and it will just long 5 seconds. We have to set up a timeout. Now we are preparing stuff to initialize the state of our application. So basically the information about an order. Okay. Then, like previously, we are asking Microcks to do the test for us. But here, because it's asynchronous, we are not expecting a result, but we are expecting a completable on a result. Somehow in the future, we will get a test result, but it will execute asynchronously. We have to wait a bit due to Quarkus DevService, but yeah, still working on this. And we are going to trigger to invoke our application. So basically to place an order. And if we have a look at place order, this is where my business logic is living. So I will do checks on the availability. I will probably persist the order. And at the end, I will say, publish that the order has been created. Calling my event publisher, and this will trigger the publication of the message of Kafka broker and so on and so forth. So I'm placing this order. I can add additional assertions like checking my order status in database, whatever. And here I wait. I just wait until the Microcks test is finished. Okay. And then I assert, checking that this test is a success, meaning Microcks has been able to connect to the Kafka broker on the dedicated topic and to read messages. Checking that we had messages and that we received one message. Simply put. If we received one message here, this means that Microcks has been able to read the messages on the target Kafka endpoint to deserialize them, and it has checked the conformance with the schema describing how an event should be formed. Okay, and here again, this can be JSON, this can be Avro, this can be protobuf. It really depends on the kind of schema that is embedded into the async API spec. And here, it's green. So in a few seconds, nearly 6 seconds, I have started everything, wired everything together. And so now I'm totally sure that what is actually produced by my application is correct regarding the spec.
So there's just a question about like the assertions. Here we do a search through test result is success, but like when it was about the rest, we had these assertions, assert success.
Yes.
So we don't have that for Kafka.
We have it. I just not updated to the latest version. I thought I had, but no.
So it's possible to test in the same way.
Yes, sure. As it was assertions. Assert success. And you can see that, yeah, these are the different flavors I was talking about earlier. So, but yes, you can do exactly the same thing. We can also simulate an error. For example, let's say that what we publish is an order event. Order event, it's a record. So let's do that. For example, here we will forget the change reason. Okay, and so for example, here it's no longer here, but I didn't change my schema. So in my async API schema, I still want to have a change reason for another event to be published. So I can run this one. It should fail. It fails because the required property change reason was not found in the message I received. Okay, so it works in the sense that it detects the crap I sent instead of the real message. So just removing this one, check back to normal. Okay. Yep. I can go further. I can verify the event content. So imagine I had some transformation rules about things that have been put into the order event at the beginning. I can just copy this part and say service test. Yes, it's here. And say, for example, yep. Jackson object mapper, yes. My preference. So here I'm using this API, get event message for my test case. So a test case related to test result and this operation I am testing. I get some unidirectional event in Microcks. Check that I got one. Sometimes invoking a business method may fire many more events. Here we just want one. And check the different elements of the message. Okay, so here I'm using the brute force approach, just using a map. If you had put something like, let's say, a cloud event or something more structured as your event message, you should be able also to deserialize everything and just check the structure of the cloud events, checking the correct headers, the routing headers, and so on and so forth. I don't know, are you using cloud events or this kind of envelope wrapping on top of asynchronous messaging? Not really. Are you using cloud events?
We are starting.
Okay. Okay. So here, after that, it's really up to you to serialize and to do the extra checks. Okay. Now, latest one, and I think we're good regarding timing. Final test. Now, let's focus on the other part. What we want to check here is that our application is able to connect to a Kafka topic, is correctly listening to the Kafka topic, and that on incoming message coming, just landing on this topic, message will be consumed and they will trigger the correct business method. So typically, when I receive the message saying this order has been reviewed, it should be consumed and the status of the order should be changed to approved, non-approved, reviewed, unreviewed, whatever. Okay. Here, the approach is a bit different. I would say, personally, I find it very elegant. So let's start creating a new class. New order event listener test. Okay. I find very elegant because it's just asynchronous stuff, and we just, in fact, have to wait. Inject. JUnit. This one is for, right, yes. My order class, sorry, big fingers. The last one. So here, our test is just to wait. Wait at most 8 seconds. And we wait until we receive an order with a specific ID. And no, we wait until we check that this order with this specific ID is in the data store, is in the database. It matches the expected customer, and it matches the expected status, plus the product quantities, description, and so on and so forth. So we are checking this every 400 milliseconds. If the order is not there, we hope that it's because it's not yet there. Okay, so we will loop until 8 seconds maximum. And if finally we are just exiting the test here, it's because we didn't receive anything in the expected delay. But you may wonder, where does it come from? Where this ID come from? In fact, this ID just comes from here again, the samples that are in your specifications that have been detected by Microcks. So typically, if I look at the this order events, async API might be this one. Let me check. Is it this one? Yes. Here in my spec, I have defined an example of correctly reviewed, validated order event with a specific ID that I define myself. And so from the beginning of the test, you know, Quarkus will start all the dev services, will start Microcks. And so because this event is there, it will start publishing this event at a defined frequency, 3 seconds. And here, it will simulate the fact that we have another component, the billing domain that is sending us some messages. And so here, I'm just waiting for this message to somehow, at some point, be discovered and be present on the Kafka topic and triggering the correct business method. So just have to start to wait, putting some guardrails using timeouts, and that's it. Here, I have testing. I am able to consume a message and trigger the correct business method on the message consumption.
The good thing is you don't have to use a Kafka companion for the test to interact with Kafka to fetch the event. The drawback is you have this ID which is in 2 places, and well, if you write a Kafka companion test, you would have the ID in the same file. So it's
yes, exactly. This is the drawback here. Yeah.
use Microcks as an injector.
Yeah. And here I would say, I didn't, yeah, I haven't done things the best way possible because typically I've put my example into the async API file. But I would say that this example is very local to my use case and to the test I've written. So it would have been better, in fact, to remove it from the async API file and put it into another YAML site file that is specific to my use case. And that's why also that's an illustration, I think, what the tool offers in terms of flexibility is that you can use the async API file that is just provided by the billing domain. That is the source of truth of the billing domain. Then
You had your own.
yes, you have your own files to specify your own use case and your own way of using it with your local samples and local additions. So typically here, yes, if you look at the sequence diagram, it's a bit messy, but I wanted to, have the, take the exercise of putting everything, but this is really what happens under the hood with the Microcks being initialized and publishing messages each 3 seconds. The other event listener pulling Kafka for getting messages produced on the review topic, and then triggering the other service with the test that is just here at the far right, having this waitability loop for checking that stuff's happened. And I think we did it. That's a wrap up. Just at the end. So we covered everything. We covered from basic thing, wiring Microcks into your application to allow you to, not having to take care about your dependencies, just gathering your contracts and let it produce simulations on the fly for you. We covered all the things related to integrating it into, for example, for having a deep dive test of a client, and then using it extensively for doing contract testing, whatever the different checks you want to apply. Could be syntactic checks or semantic or business constraint validation checks, this kind of stuff. And finally, all the things related to async. So you see that the first part was very similar. It's just changing the testing strategies, switching to async API and switching to a more asynchronous way of doing things, of validating things. And then if you're just checking a consumption, it's just a matter of waiting, putting guardrails, depending on your SLO, SLA, and so on, and just validating. That stuff happened at some point. Is it, yeah.
Do you have a Microcks t-shirt for us?
Not yet, but it might be. Next batch. But I've got stickers. So if you want some stickers, feel free. I have plenty of them, so take a lot of stickers, share stickers with colleagues, with teammates. Stickers, yes, there are stickers on the laptop, so it is allowed to have stickers on your laptop. Yeah, it's cool. Any question? What do you think? Is it easy? Too complex? In between?
It's not easy for now because we haven't had our hands on it. So.
Need to digest by playing with it. Yeah.
Can you?
The fact that the choosing the service is a string is unavoidable.
Would you like to have it instead?
I don't know. Kind of autocomplete, but then we go into another world. So
really open to any suggestions. So at some point, I was thinking about having the ability to, to just say, hey, reuse the service coordinates or extract the service coordinate from this contract file. Whatever it's called, it's not my problem. I know that this is the source of truth file I want to base my test upon, and it's doing dynamically. I don't know. So, yeah, really, we also to brainstorm about what could be next and what could be the future enhancements. So, if you think that, yes, from convenience of use point of view, it's better to have it differently, I'll be very happy to. What I've seen on the field that some people are now managing this in, let's say, not a pump, like a pump.xml, but having some kind of interface where they are declaring the name and the version of third-party services they rely on, and so they are reusing those constants on the different tests. Just another way to do things, but yeah.
I was surprised because you have contracts everywhere, but you do code first when you generate the endpoint. You didn't generate
You mean on the Microcks code base?
Yeah,
exactly.
The endpoint was written by hand with the add path. You didn't inherit from some generated open API generator stuff. Or...
Yes, yeah, could be enhancement. Yeah.
So there's a risk of error there.
There is a risk of error, clearly.
But you have the contract. So
Yeah. No, could be refactored, saying he has to use the Open API client generator for Java using using some stuff also like MapStruct for mapping API model to the business model and this kind of stuff. Yeah. I also, so try to make a code base that is not that different. That's the one people usually see. To have some kind of common ground that can be easily understandable.
And you do contract first at values or
Yeah.
I used to. It's true, but
let's write an Amadeus flavor of this workshop. In fact, so it will be totally tuned.
What we are trying to do in what we call SCube, which is kind of the Amadeus quick start and some libraries for proprietary patterns or technology. And we are actually trying to do the archetype for the contract test and have it running in our different CIs and local dev, remote dev, and all the Podman networking stuff, which apparently doesn't work on Jenkins, but yeah, we have to find ways. So yeah, working on that with a team in Bangalore.
Excellent.
So we'll see.
Excellent.
Yeah, I have a question because it was really a developer workshop. Do you have the same for PTA, from business analyst or whatever? Because everyone has seen the dev service, but you have a real UI behind the scene where you can trigger real UI.
Yes.
Where you can trigger the same, the conformance test. You can also run them from the UIs.
Yes. Not exactly a workshop. We had we have some, let's say, tutorials or blog posts that are much more focused on the UI and that explain, for example, contract testing. I have one on Medium that is doing this. That is check this one. Is much more toward how to use the UI and explain the same context and how to launch stuff using the UI. Here we have also the business constraint part. So, but not a real workshop like this one. Yes, this one was much more tailor-made for developers to learn tech.
So it could be interesting to show because the QA may write robot framework test for the system test. Today they may not be conformance tests, so maybe it could just call the API in Python to Microcks and maybe the same.
Yeah, it could make sense at some point because so when you have ephemeral instance of Microcks, of course, is make less sense. But if you are using it in a centralized way with an instance that is always up and running, you can also have this kind of history that is recording in the database with the computation of quality scores, conformer index, and so on. And so see that you can execute and have the history on different generation, different strategies of test.
looping, retrying or
No.
so you run, you have your kind of
Yes, but the test execution should be triggered by another third party, typically your pipeline, your CI/CD, your GitHub Action stuff, and so on. But it can be executed by Microcks and reported and stored within a single instance. This could be also a way of doing things.
So
I think that's it. Thank you very much. Try it out. Give us feedback, suggestion for enhancement. Yeah, that's it. And if you want some stickers, there's a lot of stickers.
and you will be there tomorrow near the canteen at lunchtime.
Exactly. If you want for a booth. And if you want to come discuss for more demonstration, if you want to see some other topics, talking about deploying this on Kubernetes, using the operator, yeah. We'll be there to notice date. Thank you.
Thank you.
Thank you.